Alright, welcome everybody. So in the previous video we did this example and I realized I made a mistake with how I made the rectangle. I made a 2 by 3 instead of a 3 by 2, but it won't matter. So yeah, like in the video, the previous video, the rectangle was like this. It should have been vertical, but it won't make a difference the way you set it up, as long as you have the right amount of squares. So 3 times 2 is 6. I have 6 squares. It'll still be okay. So yeah, here going into this example, I asked you to try and do this example by yourself, so I'll just do it really quickly for this one. Yeah, so like notice that either way you would have done it, you would have got the same answer, but this 2x squared to this x squared plus x plus 1 looks like this, the 10x to this looks like this, the 1 to this looks like that. So then what happens when you actually multiply it? 2x squared times x squared is 2x to the 4th. Then 2x squared, let me draw some arrows so we could be, let me use a different pen. Yeah, here we go. So like if I have this to this is that. Here to here, if I have 2x squared times x, this is 2x cubed, because there's that invisible 1 and you're doing the 2 plus 1 is 3. 2x squared times x, 2x squared times 1 is 2x squared. This becomes this. 10x times x is 10x squared. 10x times 1 is 10x. And then 1 times anything is the same thing. So bam, there we go. Now, what do we need to do? We just need to combine the like terms. So notice that this 2x to the 4th you can't combine with anything, so we leave it here. This 2x cubed and 10x cubed becomes 12x cubed. Here, so like this is done, this is done. 2x squared plus 10x squared plus x squared becomes 13x squared, because this is 10 plus 2 is 12, and there's that invisible 1 as a coefficient, so this is 10 plus 2, 12 plus 1, 13, yeah? So this is done. This is 10 plus 1 is 11x plus 1. Okay, oops, sorry, I realized I cut off the video. Okay, so that should have been your answer or solution for this question, whether you did distributive or box method. Okay, so let's take a look at the next example I would like for us to do is this one. If you turn the page, you should have page number 2 should look something like this, where you have x minus 1 times this x cubed plus 6x squared minus 5. So what I'm going to do is I'm going to do this problem using the box method and the distributive method. Okay, so let's do this question doing the box method, yeah? So notice that here, what's my setup? I just put the x cubed plus 6x squared minus 5 like this, and the x minus 1 over here. And notice how I'm consistent with my signs. Okay, so how do we do this? Here, negative 5 times x is negative 5x. 6x squared times x is 6x cubed. X cubed times x is x to the 4th. Minus negative 5 times negative 1 is positive 5. Okay, so you have to be careful with, you have positive and negative symbols. In the first example that we did over here with B and C, here everything is positive, so it felt much easier to do this problem. For this one, we have to be conscious about the negative symbols. So 6x squared times negative 1 is negative 6x squared. X cubed times negative 1 is negative x cubed. Okay? So now we just have to combine the terms. Let's start with the highest exponent, this x to the 4th. Can you combine with anything? No. This 6x cubed and negative x cubed, so if I have, I'll just do this work on the side, 6x cubed minus x cubed is 5x cubed. Okay, so I'm going to put that over here. So this is done, this is done. Negative, yeah, so this is done. Now, I don't want to look at this one. I want to look here at the x squared, because you want to go from exponents from highest to lowest, right? So we have 4, 3, 2. Now this cannot combine with anything. This cannot combine with anything. And this cannot combine with anything. So that's it. We're done. Let me zoom out a little bit. Okay. And that's it. This, you should have gotten something like this. Okay. So that was using the box method. Let's do the same thing using the distributive method. Now notice how the question does say x minus 1 times this x cubed plus 6x squared minus 5. So if you're thinking, oh, Mr. G, why did you, switch the order? Notice that we're multiplying, right? We're multiplying this polynomial times this polynomial. There's that invisible multiplication. Here, multiplication is commutative. A times b is the same as b times a. So what do I mean by that? Like if I say, hey, what's 5 times 2? Right? What's 5 times 2? It's 10. But it's the same as 2 times 5, which is also 10. So you're allowed to switch the order during multiplication, and that's what I just did. Okay, so here, what's the game plan? We need to multiply this x cubed times the x times the minus 1. So then this becomes x cubed times x minus 1. Okay, what's the next one? We got to do this 6x squared times the x times the minus 1. Yeah, so it's 6x squared times the x minus 1. Now here we got to do negative 5 times x minus 1. I see a lot of students when they first start learning the distributive method, they forget to put the symbol here. It's not a positive 5, it's a negative 5. Okay? And then you just trust yourself, right? X cubed times x is x to the 4th. X cubed times minus 1 is negative x cubed. 6x squared times x is 6x cubed. 6x squared times minus 1 is negative 6x squared. This is minus 5x plus 5. Okay, because negative 5 times x is negative 5x. Negative 5 times negative 1 is positive 5. My bad. Camera angle was bad. Okay, so yeah, and notice how these values, all these terms are here. Like this x to the 4th is there. This 6x cubed is there. This negative x cubed is here. Negative 6x squared is here. Negative 5x and positive 5. So you're just gonna get the same thing, and then when you combine the terms, same thing you get with that. Okay. All right. What I want you to do is on your own try and do this one by yourself. This one will be a little more extensive, right? So we have to make a 3x3 box, right? Well, actually, at this point, you do you. If you like the box method, and if you feel like you want to work on the box method doing this example, go ahead and do that. So if you want to do the box method with this, go ahead. If you feel like you like the distributive method, go ahead. Box method is kind of like training wheels when you ride a bicycle. Like first you need the training wheels, and then you kind of like ride the bike on your own. So if you feel like you need the training wheels, which is okay, you can go ahead and do that. But this is more of the classical approach. You should get into the habit of doing this versus making the box, but you do you, yeah? All right, I will see you in class. Try and do this example, and then we'll go over it together.